Today, we're going to dive into what is, without a doubt, the greatest story ever told, our own. We're going to trace the epic 15 million year journey that explains how we, Homo sapiens, came to be. Our source material really gets you thinking about this one central question. From the earliest primates all the way to the dawn of civilization, what were the key moments, the crucial evolutionary leaps that made us who we are today? That's the big mystery we're unpacking. So to find the answer, we have to rewind the clock. And I mean way back. We're talking 15 million years ago to meet the primates that really got the ball rolling. Okay, so on the scene back then were two key players, Dryopithecus and Ramapithecus. Now the distinction here is pretty subtle, but it's super important. They were both hairy, and they both walked a bit like modern gorillas and chimps, but the fossil record, things like jaw shape, suggests that Ramapithecus was already leaning a little more towards the human line, while Dryopithecus was more traditionally ape-like. This is that first tiny split in our family tree. And this timeline really shows you the immense scale we're dealing with. After Ramapithecus, there's this huge gap of more than 10 million years in the fossil record. Then, damn! Around 3 to 4 million years ago in eastern Africa, a total game changer appears. Primates start walking upright. Just a million years after that, we see the Australopithecines not just walking, but using tools, actually hunting with stone weapons. This brings us to a really pivotal chapter in our story. After millions of years of these early man-like primates, a new kind of creature emerges, one that scientists decided deserved to be in our very own genus, Homo. See, among the bones they found from this period, some were different. They belonged to a creature that scientists called the very first hominid. This wasn't just another upright ape. This was something on the direct path to us, mainly because of its brain size and the way it consistently used tools. That creature was Homo habilis, and it marks the true beginning of our own genus. So what made Homo habilis so special? Well, a huge part of the answer was inside its skull. Its brain capacity was between 650 and 800 cubic centimeters. Now remember that number because it sets the baseline for one of the most dramatic trends in all of human evolution. All right, let's move to our next ancestor and see how things progress. About 1.5 million years ago, fossils show a new species, Homo erectus, and with them, two major changes. First, an even larger brain. And second, something new on the menu. The evidence we have suggests that Homo erectus was the first of our ancestors to eat meat. So just how much bigger was that brain? We're talking around 900 cubic centimeters. That is a significant jump from Homo habilis. You can almost see this powerful feedback loop starting here. Better tools and new, high-calorie foods like meat provide more energy, which in turn fuels a larger, more complex, and way more energy-hungry brain. Now, the next evolutionary leap isn't just about brain size. It's about what that bigger brain could actually do. We're now entering the era of our most famous relatives, where we see the first real, concrete signs of complex culture and abstract thought. It's time to meet the Neanderthals. They lived between about 100,000 and 40,000 years ago, and they were a super successful species. And just look at that brain size, 1,400 cubic centimeters. To put that into perspective for you, that's actually a little larger on average than the brain of a modern human today. This chart just puts that incredible growth into sharp focus. From habilis to erectus to the Neanderthals, you see this absolutely explosive increase in brain capacity. The big takeaway here is that for millions of years, evolution was heavily and very successfully selecting for one thing: intelligence. But it wasn't just about raw processing power. The Neanderthals show us the first stirrings of what we'd call culture. They used animal hides to protect themselves, a clear sign of planning ahead. And even more profound, they buried their dead. This is huge. It implies social bonds, maybe even ritual, and the ability to think about things beyond the here and now, like life and death. And then there was us. While the Neanderthals were thriving in Europe and Asia, our own species, Homo sapiens, emerged in Africa. And from there, we began this incredible, unprecedented journey, spreading across continents, adapting to every environment, and eventually populating the entire planet. The age of modern humans had officially begun. So the final piece of our origin story isn't really about physical evolution anymore, but about a cultural revolution. There were two key developments by early Homo sapiens that would fundamentally change our relationship with the planet and pave the way for everything we now call civilization. And look how fast this happens, at least in geological terms. About 18,000 years ago, we see this incredible flourishing of symbolic thought in the form of cave art. Then, just 8,000 years later, we figure out agriculture, which changed everything. For the first time, we didn't have to wander around to find food. This let us create permanent settlements, which led to bigger populations, specialized jobs, and the complex societies that became the world's first cities. Our source material actually gives a fantastic example of this artistic explosion: the cave paintings at the Bhimbetka rock shelter in India. I mean, these aren't just doodles. They're sophisticated pictures of their world, a clear sign of a mind that can think abstractly. This, followed by the global invention of agriculture just a few thousand years later, were the two final innovations that set the stage for the modern world. And from those first settlements, well, everything else follows, right? The rise and fall of civilizations, writing, science, technology, all of it. Our evolutionary journey brought us to the starting line, and our cultural journey is the race that we've been running ever since. So we've traced the single line of ancestors that led directly to us. But our journey wasn't just a straight line. It was more like a big branching tree. And this brings us to a final, really fascinating question from our source material. The term adaptive radiation is what happens when one species rapidly diversifies into many new ones to fill different roles in the environment. Think of Darwin's finches and how they all evolved different beaks for different foods. So when you look at our family tree, with all the different hominids that coexisted, habilis, erectus, Neanderthals, and so many others we didn't even cover, can our evolution be seen as a similar kind of explosion? It suggests our history isn't just a simple march of progress, but a story of wild experimentation, with many paths taken, and only one ours surviving to today. That's a great question to ponder, now that you've seen the whole incredible story unfold.